In this session, we are going to see about Introduction to IoT Part 2. These are the topics we are going to cover in this session. First one, the address crunch. Address crunch is basically the shortage of IP address because of the rapid growth of devices connected to the internet. What does it really mean? Every device that connects to the internet needs an IP address. In early days, IPv4 provided around 4.3 billion unique addresses, which seemed like plenty at that time. But now, the billions of smartphones, laptops, IoT devices, even home appliance connected to the internet, we are running out of this address. Let's take an analogy. Imagine every house needs a unique number to receive mail. Now if every bulb, fan, fridge, AC also needed its own number, you would really quick run out of numbers on the street. Similarly, the internet runs out of IP address when there are too many devices. I also wanted to add some facts. For example, IPv4 has 4.3 billion addresses, but it's not enough for us, no. So we are upgraded into IPv6, which solves this issue. With 340 undesigned addresses, a number so big it will never run out anytime. Let's relate to it by using a meme. Let's consider Dhanush as the IPv4 and let's see the meme first.
நான் சிரிக்காத சொன்னா எனக்கு அசிங்கமா இருக்கு.
IPv4 is Dhanush. IPv6 are the people laughing at him. They are laughing because IPv4 is actually old version with a low number like 4.3 billion addresses, but IPv6 have 340 undesigned addresses. Okay, let's see the next topic. Connectivity terminology. In this we have 5 subtopics: LAN, WAN, node, gateway, proxy. LAN is local area network. For example, in our home we use hotspot, Wi-Fi. No, that's example for that. WAN connecting number of LAN makes the WAN. For example, connect 4 houses which uses LAN, it's become a WAN. And IoT node is a smart device, a sensor, light bulb, like that. Gateway, the Wi-Fi router or hub. Proxy is a software which for example we can take Alexa, Siri on behalf of device to communicate with each other. We use it. IoT network configuration. Main idea is device use local addresses within networks. Multiple networks can reuse local addresses with help from gateways. Real-time example, in your building, 3 flats might have devices named smart fridge, but they won't clash because the flat is the gateway, as its own local network. Gateway means, for example, in our college, the entrance is the gateway. It checks who comes inside and who goes outside and gives a partial security. It's an example for gateway. And gateway prefix allotment. Main idea of gateway prefix allotment is gateway uses unique prefix to manage device address without conflict. For example, we can take like for laptop we are using the IP 192.168.1 means for phone we will use 192.168.11. Like that we can change the prefix and use it continuously. For that I can give an example. Each house gets a street name, house number. Similarly, each gateway gets a prefix and its device get unique local number. This avoids address confusion across homes. We can see a meme for that.
இப்ப என்ன வேணும்?
நீங்க யாரோடயோ பேசுற மாதிரி பேசுங்க, நானும் யாரோடயோ பேசுற மாதிரி பேசுறேன். பாக்குறவங்களுக்கு டவுட் வராது. அதுக்குதான் இந்த மெத்தட்.
யாரோ பேசுற மாதிரியா? நீ யாரோ தான்.
Without changing the prefix, if a local address enters into another network, it can't identify it and it won't allow to use that local address. Like that, if we take a SK for local address, the girl who is talking is the new network. She don't know that device if he didn't change this prefix. Okay, let's see impact of mobility on addressing. In this picture, we can clearly see what's happening in this. Like device can move from one place to another, but their local address stays the same. Gateway they connect to takes care of adapting to new network address, so communication doesn't break. For let's take a simple example. Imagine carrying a mobile ECG device from one hospital to another. At each hospital, it connects to different Wi-Fi network. Even though the network addresses changes, the device local address stays the same, so communication continues smoothly. In other words, the gateway handles the changes, so you won't lose connection. Important points in this slide is mobility supported by keeping local address stable, but while gateways handle the outside network changes. Useful in IoT, healthcare, transport, and mobile networks. Gateways. The main idea of gateways handle communication inside and outside of IoT network. For example, your smart fridge talks to your smartphone via the router. Gateway manages addresses and also updates the fridge software by connecting to the company server. Like let's see a meme for that. This man is the gateway and someone walking through the stairs is the data, or someone want to enter into the gateway.
காட்டு மிராண்டி மாதிரி இருக்கா அவன் தலையும் முடியும் ஒண்ணுமே அண்ணன். ஏய் என்ன நீ பாட்டு கேட்ட திறந்து உள்ள வர்ற கூடு கூட ஏறி மேல போயிட்டே இருக்க? யார் நீ?
பாப் மல்லி. பாப் மல்லினா
இது பாலமுரளியா? ஏய் நில்லியா?
Okay, let's see the proxies. The main idea of proxy is to help weak devices by handling their heavy tasks, control, filter, and forward data. For example, a tiny motion sensor sends raw data to a smart home assistant that analyzes it and decides whether to turn on the lights. It's actually filtering that data, no? So that I added a mean for that.
உன் பொண்டாடி உன்னை செருப்பால் அடிச்ச கதையெல்லாம் நான் கேட்கல. அன்னைக்கு மதியம் 1 மணிக்கு மாமா பக்கம் ஆஸ்பத்திரிக்கு வந்தியா? அப்போ உன் காலில் என்ன ஓதுனாரு அதை மட்டும் சொல்லு.
Okay, let's see about IPv4 versus IPv6. The main idea, IPv6 has more addresses, better features. IPv4 is outdated but still widely used. Like already seen that IPv6 has 340 undecillion addresses, but IPv4 only has 4.3 billion addresses only, no. But still we are using IPv4 more than compared to IPv6. For example, IPv4 is like using 4-digit phone number. Eventually we run out. IPv6 is like using 12-digit number, enough for every device you can imagine. For that we added a me. She is the user of IPv4.
அப்ப கூட அந்த பையன் என்ன கேட்டான், நீ என்ன லவ் பண்றியா இல்ல எங்க அப்பாவை லவ் பண்றியான்னு. சத்தியமா உங்க அப்பாவை தான் லவ் பண்றேன்னு சொன்னேன். இதெல்லாம் நடந்தது.
Okay, let's see about multi-homing. The main idea is a device connect to multiple networks simultaneously. For example, both Wi-Fi and mobile data, or 5G and satellite internet. If one network fails, the other keeps the device connected. The device or system manages multiple IP addresses automatically without you noticing. For example, a self-driving car uses both 5G and satellite internet. If 5G signal drops, satellite takes over instantly. It ensures continuity and is essential for safety. Why it actually matters? Prevent interceptions for critical systems like autonomous cars, online banking, medical devices. It improves speed, reliability, since the device can choose the best network at any moment. We can't rely on only one device for safety. No, that's why we came up with multi-homing. Tunneling. The main idea of tunneling is it's actually tunneling and proxy, I think. Main idea, IPv6 transition is slow, so we use temporary fixes like tunneling and translation. For example, like having to connect between English and French when two people don't speak the same language. Translation tools help them communicate. Like tunneling without encryption, intercepted or stolen. Like we can use tunneling to fix this issue, but without encryption it is dangerous. The data can be intercepted or stolen, and for that we added DME.
உள்ள அழுவது தெரியுது, வெளியே சிரிச்சுக்க என்ன பண்றது? இமேஜ் இமேஜ்.
Okay, let's see about sensor and activators. Sensor is the one who is doing all the work. Like for example, take a fan. The fan is running because the sensors are working, and the switch is for activator. Consider like that. Just clicking the switch, the sensor are working, the fan is running. All the credit is taken by the switch. Like we are tapping on the switch and the fan is running, like that only we will tell. We don't talk about the sensors. It just activates the device. That's a work of activator. Sensors are sweating versus activators flexing. Sensors collect and transmits non-stop. Activator just waits and goes that once and takes the credit. Okay, let's see the summary. Imagine a smart farming system, soil sensors, which are the nodes, and data goes to the local controller, which is the gateway. Gateway sends information to the cloud via WAN, a wide area network. A proxy processes it and triggers irrigation when needed. Even if the farmer takes the controller to another field, it still works due to local unit and prefix mobility and handling. And
இவரை வச்சுதான் எல்லாமே நான் பண்ணிட்டு இருக்கிறேன். இவருதான் தெய்வம் தெய்வம். ஏதாவது சுய கட்டுப்பாடு, சுய ஒழுக்கம், அன்பு எல்லாத்தையுமே கொடுக்கறது இவரு தாங்க. இவர் முகத்தை பார்த்தா போதுங்க, கருணை வந்துருங்க. யாருக்கு எந்த துரோகமும் செய்யறதுக்கு வராதுங்க. நல்ல மனிதருங்க.
And IoT network configurations. These are the local networks connecting multiple local networks. We can have WAN, and it is the internet IoT proxy, local units connected to it, and it's a gateway node. And we have this comparison between IPv4 and IPv6, and these are the things we already learned at class. IPv4 format, IPv6 format. We can see a lot of difference between both.